Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar, How Open is the Future RAN, sponsored by Picocom. Our speakers today are Peter Claydon, President of Picocom, and Monica Paolini, Principal at Senza Fili. We had originally intended to have Ravi Sinha of Reliance Jio join us this morning, but unfortunately he was unable to attend at the last minute, so we'll be missing him today. In Sparring Partners webinars, we watch our debaters discuss a topic live on video. We would like to encourage our audience to participate in the conversation. Please share your comments and questions using the Q&A button at the bottom of the Zoom screen. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed, so please do not hold your questions until the end. And one final tip for our audience, our speakers generally do not monitor the chat during the webinar, so feel free to share both comments and questions in the Q&A box instead. With that, I'll hand it over to Monica.
Well, thank you, Kendra, for introducing me, and it's a pleasure to be here. Sorry we don't have Ravi with us today, but we will have a great conversation, Pete and I. We actually already had a conversation quite recently on Open RAN, and that's available, and I will post a link later. And we talked about Open RAN, and I encourage you to read that. Today, we're going to talk about different topics. However, Open RAN is a huge topic if you start going deep into it. And this is also a follow-up on a report that I recently published, and I'm going to post a link to that soon as well. So to today's topic, we're going to talk about the future of the RAN and on Open RAN. And the title is the future RAN open? And the reason for that is because we often think about Open RAN versus traditional RAN as two different things that are fighting each other for world dominance. And I think that we should take a little bit more of a nuanced view. There is a lot in between. There is a lot of ways in which the traditional RAN and the Open RAN can evolve. And so there is really much more than one solution against the other. And so in that spirit, Pete is a perfect person to talk to because he's working on both ends, and he's been, not only working a lot, but thinking a lot about those issues. So it's really a pleasure to talk to him today. So as usual, we will take, as Kendra said, we're going to take questions from you as we go along. So if you wait until the end, chances are that we're not going to get to your questions. So feel free to ask your questions as we go, and we'll take them as soon as we can. We will just have a free-flowing conversation. And Pete is a great person to do that with. So before we get into the discussion itself, I would like to ask Peter to introduce himself. What is he doing on Open RAN, and what is his perspective? Where is he coming from? So Pete, thank you so much for taking the time to be with us today. And please let us know more about yourself.
Well, thank you, Monica. Yes, it's a pleasure to be here. So yes, I'm Peter Claydon. I'm president of Picocom. So the probably best way to introduce myself is to tell you a little bit about Picocom. We're a semiconductor company, and we develop semiconductor solutions for Open RAN. That's 4G and 5G, but specifically Open RAN. So our major products at the moment, we have a chip called the PC802. This can be used in a variety of contexts. It has different versions. So in terms of the O-RAN Alliance splits, it could be, it actually contains a full PHY, the lower PHY and the upper PHY, and also the Open Fronthaul eCPRI interface. So you can use it with the upper PHY and the eCPRI interface. It form part of a DU, the physical layer. The lower PHY and the eCPRI interface, that's parts of an RU, a radio unit. And you can use the upper PHY and lower PHY together, which would be typically part of an integrated small cell. So the upper PHY, also looking at Open RAN, is something that's broader than just the O-RAN alliance. Part of it is in fact the FAPI interface, which is being developed by the small cell forum. It's been something that's been in existence for all through the 4G era, and it's got 5G versions now as well. And this is the interface, the open interface between the layer 2 processing and the PHY layer, the layer 1. And this is something that really kind of I think almost everyone conforms to, or pretty much conforms to. So whether you're using a Qualcomm solution or a solution from Marvell or someone's proprietary solution for the PHY, whatever layer 2 you're using, there's this FAPI interface will be there. So that's the software interface to our chip. So we've had our products in the market now for over a year, and so we get to go and talk to a variety of customers and prospects throughout the world. So we have a really good idea of what people are actually doing today and what they're actually wanting to do.
Yeah, absolutely, and that's quite interesting. And actually, when you think about FAPI and the small cell forum. Again, if you think about sort of the overall evolution of the RAN, there is really way more than just the O-RAN alliance in terms of opening interfaces, in terms of disaggregating the RAN because there are different levels in which you need to operate. And I think that it's just important to really look at it that way. Sorry.
Yes.
Yeah, sorry, I thought you wanted to say something.
No, sorry, carry on, Monica.
Yeah, so let's just start talking about actually small cells, because when we think about Open RAN, there's different views here. Is well, you're going to get started in rural areas, you're going to start in metropolitan areas for this and that. But so the question is that, how do you see Open RAN and small cells fit together? Is it what's the advantage? Are the new small cell deployments going to find beneficial to an Open RAN architecture?
I mean, I think it's interesting you should mention, lots of operators saying they're going to start with Open RAN solutions. Indeed, have started with Open RAN solutions in rural areas, and this is kind of a codification, I think, for being something that's not massive MIMO. So when operators have been deploying 5G in dense urban areas, they've been using 32T, 32R, or 64T, 64R massive MIMO for FR1. Whereas in rural areas, they've probably been deploying 4T, 4R. So when the O-RAN Alliance developed their open front haul based on eCPRI, that works fine actually for not for massive MIMO. So where it actually has trouble is with massive MIMO, which maybe we can talk a bit more about later on. So for the way that particular standard, Open Front Haul, which is how a lot of people thought about Open RAN, or was kind of essential to it, and indeed it's important, that's very suitable for small cells. So 5G small cells, that particular split 7.2, is good for dense coverage, either in-building coverage or campus coverage. So it's actually more appropriate to that, in fact, than in many macro cell deployments. I mean, but I guess the thing overall about Open RAN is that that's almost kind of come on, not as an afterthought, is actually the management system and the RIC and how that works, and that's really applicable across any sorts of split. It's how you manage functions within the RAN, and it doesn't really matter whether those functions are part of an integrated unit or they're split apart. They can still be managed through that same mechanism.
But couldn't you also have, say, RIC and manage your RAN, used in RIC, even without Open RAN?
Well, I mean, I guess RIC is part of Open RAN, the RIC. So, I mean, for those, just to kind of I think most people on this call are familiar with the general concepts of Open RAN, but you're dividing the actual what used to be a base station, an E node B or G node B, into 2 or 3 different parts for various reasons, and those parts are still within that whole ORAN framework. There's a management function that goes on through all of those being connected together through various interfaces to the RAN intelligent controller. And the thing about the RAN intelligent controller, which gets a lot of mobile operators excited, is that you can actually plug in things to that manage, a standard network. And that standard network, yes, could be, it could be, as you say, almost nothing to do with Open RAN. It could be actually things that were more integrated small cells, or integrated base stations, but in this case, talking about small cells. So you can still plug those into that mechanism. And if we go back to the 4G era, where we had E node Bs and EPCs, then for a long time you'd be able to buy a base station, an E node B from one vendor, an EPC from another vendor. You'd expect though to put those together, and on the whole, it would work. It would just work for the the C plane and the U plane. You get that functionality working. The difficulty that mobile operators always had with this was, how do I plug that into my management system? So that's the thing that will make it very difficult to take hardware from different vendors. I mean, there are other things as well. There's the, how do you sort of connect different base stations from different vendors to each other through an X2 interface? But the overriding thing there was the management system, and that is something that ORAN probably not there together, the Open RAN, but there are various mechanisms in there which could, by solving that management problem, it's something that you can then it will allow operators to actually buy equipment from more than one vendor.
Absolutely, and I guess a different way to look at it is that the sort of conceptually, the distinction within RU, DU, and CU, it's helpful in managing the system. Then how you implement it from a hardware point of view, in a way, that's the whole point, right? It's disaggregated, you have a choice in the solution, but gives you a way to manage the RAN that is new. Yeah,
precisely. That's right. So the implementation of it, is not really relevant to overall the benefits of Open RAN. Yeah, because the sort of the strict version of what Open RAN is, and what some people sort of think, or at least that's sort of the core, is the DU-CU interface. That's defined. So if you have that, then you have Open RAN. But Open RAN is way more than that, and in a way, that's just like, I wouldn't say detail, but it's sort of like it's the foundation of something that has much wider implications. Yes, I agree. It's I think it's over the last, say, 3 or 4 years, there's been a lot of focus on these actual interfaces between units, and that's something which is necessary if indeed you have separate units there, but that's necessary to make the thing work in the first place. But that's not really where you get a lot of the more fundamental benefits of using Open RAN. Yeah, absolutely. Okay, so let's go back, because we don't want to spend the whole hour talking about small cells. But let me ask you: so why is it so? The advantage of having small cell using Open RAN is just the same as every other macros or any other element, right? I mean, so the issue is that if you use it in the macro, why not in small cells? I mean, it's basically the same value proposition. It is. Sometimes people say, well, since it's a small thing, well, we don't really need to bother with Open RAN. And I think that's really not the issue, because you need to manage small cells within your bigger network. And so, you need to manage them. You need to be part of the system. And so you want to be on Open RAN as well. You do, and I think in the 5G era, far more people, it's all of these, different cells using the same spectrum. So you have to have management that goes across macro cell and your small cell layer. In 4G, to some extent, some operators will have a small layer that was separate from the macro layer, so you kind of treat it as more independent. But I think now operators are wanting to actually be able to just manage everything together.
Yeah, absolutely. What about private networks that are standalone? Is that worth it for them?
Yes, I mean, I guess most private networks, I don't know any private networks are actually using massive MIMO. And by definition, private networks tend to be geographically constrained. You don't really get national private networks, otherwise you become a MNO. So you'd be constrained to, a building or a campus or a port, a factory, whatever it is. And you're probably going to get, you're looking for some capacity within that. So you're going to have a network of what's fundamentally going to be small cells. It's unlikely you're going to have high power cells forming, parts of a private network.
Yeah. Okay. Final thing that could be, could be a question is millimeter wave. And we're going to get back to massive MIMO 2 later, but is there any difference in using Open RAN if you're sub-6 gigahertz or millimeter wave?
No, not really. I think it applies equally to both. I mean, what you're doing with it, in terms of you're doing with the interfaces, it's going to be somewhat somewhat different in terms of interference management between cells, or more likely coordination between cells. But fundamentally the interfaces are going to be the same. The switch that you use within millimeter wave could be different, although we've actually seen that people are using, all of the same sort of splits that that they're using for sub-6 gigahertz FR1. We've actually, I think we've seen when we developed our product, our chip, we made it suitable for millimeter wave and sub-6 gigahertz. Then, I guess what happened was that the US was leading the way in millimeter wave, and then the US licensed C-band spectrum and other spectrum. So all of the MNOs actually had mid-band spectrum. So the focus on millimeter wave got less for at least some time. And depending on who you talk to, people will say millimeter wave is going to come along in, next year, the year after, or 2 or 3 years time. It's obviously got its own different challenges, but that's yes, as you say, Monica, nothing to do with whether you're using Open RAN or not.
Yeah. I see you have a question from the audience, which sort of fits in, is Open RAN just a 5G thing? And I guess we can look at this question as being going backwards and forward about Open RAN for 4G or 6G. Is what's the relevance of 6G in this?
It's definitely, if you look at, it's a good question. It comes to, I think is it a 4G thing? Yes, Open RAN is equally applicable to 4G, but is it something which is going to be something that's retrofitted to 4G networks? If you're doing something which is a new 4G network or a combination 4G, 5G network, you can apply Open RAN to everything. But if you've got an existing 4G network there, you'd be applying Open RAN to the 5G port, the 5G network that goes alongside it or integrates with it.
Yeah. Okay. Now, why don't we talk about, since we kind of start talking about massive MIMO, continue on that track. Okay, clearly massive MIMO is going to be mostly used for macro rather than small cells. But what is the deal there? And I guess there is a question which is also has to do with the need for front haul and all that. So what's the deal? Why is it a special? What do we need to make? What should we think about Open RAN with massive MIMO? Isn't it just the same as everything else?
Well, yes. I think it's true. If you listen to particularly Ericsson, Ericsson, Ericsson have got lots of clever engineers who are probably years ahead of most other people in their thinking about things and their understanding, and they have very high performance products. And Ericsson has been saying for quite some time that Open RAN doesn't work for massive MIMO, or it doesn't work very well. And there are some fundamental things that there to do with with massive MIMO. You have a unit up at the top of the mast, and with O-RAN split 7.2, all the data goes down across a fiber to a distributed unit, a DU, and where you do a channel estimate based on what you've received, and you use that to modify the signal you're sending downlink. If you've got users who are moving fast, by the time you've done all that, your users have moved, the channel has changed, so you get less performance. So there are moves within the O-RAN Alliance to kind of change that to have a new variance of that split 7.2, but fundamentally at the moment it's not going to work as well as someone's proprietary solution, and that's going to change, and that's the reason why people like organizations like Vodafone are sort of looking, well, we'll deploy Open RAN in rural locations first, but equally well, Open RAN has to work with massive MIMO and macro cell. Otherwise, unless you just have a small cell network or a network that only involves more traditional macro cell base stations, which will be unlikely, you actually need to have Open RAN so that it will work for massive MIMO, and that's going to take another number of years. And hence, you talk, lots of mobile operators saying, well, they think it's going to come in with maybe 5G advanced or even 6G, but certainly nearer the end of the decade. And I would say that we will subscribe to that being what's going to happen, despite the fact that there's a lot of effort going into it at the moment. Yeah, but then, I mean, if you look at it from an operator point of view, if they say, okay, we need to deploy, one area, and if we go massive MIMO, we cannot do Open RAN today. We need to wait. They're not going to say, well, since we want to do Open RAN, even if they're committed to Open RAN, and a lot of operators are committed to Open RAN, but they're not really doing it right away. So, if I'm an operator, I would say, well, massive MIMO is a priority, so I'm just going to do that and then wait for Open RAN to come along, rather than say, oh, I want to do Open RAN first, and then whenever I'm ready, I'm going to do massive MIMO. Is that, how do you think that that's going to go? Well, I mean, I suppose the other point is that for those macro cell networks that are massive MIMO, all the major operators, already have contracts for the deployment of that, with the major vendors, with Ericsson or Nokia primarily. So we look at what happened I'm in the UK, so it's something that's familiar to me, but it probably happens in other places as well. Look at what happened when the UK government basically said you've got to get rid of Huawei equipment. The operators on the whole started putting in just more Ericsson or more Nokia. So rather than saying we're going to wait and go for Open RAN in those. So I mean, I guess massive MIMO and Open RAN will probably come along at the right time, when people are getting, the operators are getting to the end of their current sort of rollouts and are looking for the next phase. Yeah, and then again, it looks like the ability to deal with massive MIMO is just a question of time, and I guess this is something that in the whole discussion of Open RAN, there is sort of expectation everything should be perfect today or is going to fail, and it's never like that. Where any technology, when we got 4G, 5G, everything, when you get started, it's just there's all sorts of problems, and then you resolve them, and that's the way it always works. So we shouldn't really read, I guess, too much into it. It's not like, oh my God, and so this is just the same thing with Rick. In fact, with managing, we don't have it. It's not quite prime time yet, but we know we're going there. It's just going to take time. So I guess that's really the way to look at it, and I guess that's why
you can get started with, rural small cells, the parts that are more manageable, even though it's not ideal to just do, say, small cells, but it's a place to start.
Yeah,
I think that we need to be realistic about, Open RAN or any new technology.
Yes, I mean, a small cells Open RAN technology is certainly being used. Every customer we have really in any major customer out is using Open RAN in some form or another. Even with an integrated small cell, they'll have a FAPI interface somewhere in the middle of the cell. The interface back to the core is open, so it's all in some form or another. And we have customers who are looking at they're seeing the benefit of this as in a small cell network, as they can put intelligence in the RIC, so they can buy potentially a standard RU, maybe a standard DU and CU, and they can add something in the RIC which provides some there's some IP they got maybe there for in terms of dense networks, and I think that's quite exciting. So we've been involved with people who are doing that sort of thing, and they might still want to have their own RU because the reasons they want it will still be Open RAN, but the kind of reasons people want that is though I want to do a bit of band 3 or band 1, for example, LTE, and I also want to do a bit of band N78 5G or a lot of N78 and 5G. So they can't go and buy one of those off the shelf, but there are vendors there who, okay, that's what we want. We'll make an Open RAN RU that deals with that. So they're not buying something off the shelf, but it's still based on Open RAN principles, and it still allows them to use a RIC to add intelligence to their own network.
Yeah, is that real time or near real time, right?
Sorry, but both. I mean, I think a lot of what people are doing is non-real time. I mean, it can be how they're kind of configuring things over a period of time. I think it will move to being real time. I think it's that's probably less of a thing as yet.
Yeah, and again, I guess this is like the massive MIMO discussion. I mean, this is just something that we see it coming. People are working on it, but not quite there yet.
Yeah.
We need to look into that. I see there is another question here: is if RUDU bandwidth requirements scale with MIMO order, and could that be another consideration in using the 7:2 split with massive MIMO?
Yeah, I mean, I guess massive MIMO, you're probably going from the bottom of a tower to the top of a tower. So you just have whatever it takes. If it's 100 gig Ethernet that does that, you have 100 gig Ethernet. So it does in that sense. If you were running this over, if you wanted to go massive MIMO and have your DU more centralized, that would certainly become more of an issue. But because of the way it's likely to be deployed or is being deployed, that's thing. I mean, that's still a thing in small cells, by the way. The scaling of that split 7.2. You kind of quite quickly get over you're above a 10 gig Ethernet. You're into 25 gig or 100 gig if you start aggregating things together. And that's the reason why people may prefer in the small cell world to stick to either integrated. When I say integrated, I mean split, not split at all or split 2, because that's a logical thing to do. It's a well-defined standard interface, or indeed split 6, which has some of the benefits of having a more centralized scheduling. And a lower bandwidth out to the radio unit.
Yeah, but isn't the sort of the split decision somewhat independent on whether you have Open RAN or not? Because you just need to find the choice of the split depends on the bandwidth requirement, what kind of transport you have, whether it's Open RAN or not. In a way, you still have to deal with.
Yes, yeah,
right. I mean, it's kind of like it's sort of somewhat of a separate issue, isn't it? Or is it something specific?
No, it is. I mean, people come to us and say, do you support some strange variant of split 7.2? There's a split 7.2 A, B, and C, and we just say, well, we support open front haul. That's what we support. There are people who, there's no reason why the same things don't apply to non-standard variations of the split. But then I think it's got to the stage now, why would you do a non-standard variation of a split? You're just making life difficult for yourself.
Yeah, right. But I mean, I guess from an Open RAN perspective, whether you can have it more or less centralized, that's sort of well, that's actually the beauty of Open RAN. You can decide how centralized you want the architecture to be. You're not forced to go one way or another, right? So
yes.
Because then, but then I guess that sort of goes back to the management system. You can have a RAN that is distributed, not centralized, but it's still an Open RAN, and then you can still manage everything, all the different elements, though they are centralized and not centralized, using the same management interface. The same.
Yes. I mean, you can. I think that's one of the good things about Open RAN is you can, within the whole Open RAN context, and probably last year we were talking about as defined as zero RAN alliance, you can make decisions as to whether you're putting things more centralized or nearer the antenna, depending on what makes sense for your deployment. And that could be the availability of backhaul and front haul. It could be a range of factors there. It's the performance you require. It's whether you're happy to treat things as individual units at the edge, or whether you want to have some sort of more joint intelligence when you're scheduling data across different radios.
Yeah, absolutely. Now we have another question here. I see we have a rather technical audience. How do you see Open RAN and 6G beyond the PHY and layer 1, layer 2?
So I just gone to mute there and have a bit of a cough.
No worries. You see the question, right?
Well, I mean, I guess Open RAN, by the time we got to the interesting question, Open RAN and 6G beyond the PHY and layer 1, layer 2 layers. Well, the RAN is actually layers 1, which is the PHY, and layer 2. I mean, yes, and layer 3. There's a 6G. There's a 6G question. I mean, I suppose the thing here is this is going back to the thing that's beyond that. It is the RAN intelligent controller, the RIC, which is where you can put a lot of intelligence. 6G's got well, we think one thing that we're going to see with 6G is there's going to be a lot more machine learning, in there, that's what people are looking at the moment when it comes to the RAN. And that can go from just, I'm going to put a little bit in here, add a bit more intelligence to, the whole RAN is going to be some sort of big AI engine. Where, I mean, I guess the thing about 6G is the speculation there that people will aggregate again rather than disaggregate. I don't know this. You can still remain open, and if you're talking about things that become more software potentially, then you don't actually need physical interfaces to be open, for there to be open interfaces.
Yeah, and well, I guess that is an interesting thing. So, well, first of all, RIC doesn't seem to be part of 6G. It's kind of a parallel sort of thing.
Yes, it is.
So it might benefit from some of 6G features, but is not dependent on it.
Yes, I mean, I think 6G is probably a bit too early to talk about, 6G in the context of Open RAN. I suspect 6G will be defined in a more open way, as opposed to 5G, being defined in was something in there that 3GPP put in there to kind of, but they weren't really thinking about it, particularly being from the point of view of openness. And why should they? I mean, they're driven by, you know, Huawei, Ericsson, Nokia, and people who didn't particularly want it to be open. In 6G, I think there'll be far more a drive for it to be the underlying standards to be more fundamentally open.
Yeah, and I think you brought up a very interesting issue. You know, like in 6G, we're going to have back to more aggregation or not, and there is a question of having interfaces that are open. And they might be open to some extent. So they might be, you might have an open interface and then people build stuff on top. So it's not as open, but it's still, the foundation is open. So it's not just the necessarily black and white type of distinction. And also the fact that you sort of have the option to disaggregate, to choose different things. Like, you know, you were mentioning before with some clients that they need to have something different so they can actually do it if they want to. Doesn't mean that that's the standard way to do things. So, you know, we might find that, you know, having some sort of aggregation is actually helpful because you limit the number of moving parts, so to say, in your network. You have fewer vendors. So you want to have as many as few as you want, but as many as you need. And so it's the flexibility that having interfaces is going to bring you. That so maybe, you know, 10 years from now, I think that one possibility is that we'll look backwards and see that Open RAN is kind of an obsolete concept in the sense that everything is somewhat open, but it doesn't mean that you're going to have any number of vendors and it's going to be completely plug and play in the same way that we just can go and buy any Wi-Fi access point, plug it in our home and it works. It will never be like that for RAN. So maybe this is like right now, we're kind of a point where we're all polarized between open and not open, but eventually we just get in a situation where, yes, it is going to be open, but it doesn't mean it's going to be completely disaggregated all the time.
Yeah, I mean, it's also where people add their value. You know, we're already seeing vendors who are, you know, traditionally might be adding their value by having hardware components, but they, you know, they don't see that hardware as being a something where they even necessarily want to be there now. They would be rather quite happy to go and tell their mobile operators, go and buy some hardware for some people, and we'll provide a solution, which is predominantly a software solution that binds all that together, and we'll do the system integration for you and provide everything that makes it go together. So I think the thing there, people adding value on, you know, hardware components, even which may contain quite a lot of software, like a radio unit, for example. It's not something that's, if you're, I think, one of the more traditional vendors, you necessarily need to be doing that. I mean, some, you know, the big vendors could actually, you know, they do make substantial business, which is over and above any hardware they're actually providing. So I think focusing on a lot of splits and things and how things are, you know, that does play more into at the end of the day, when we a few years on, possibly no one will really care about that, because it will all be more at a software level or an integration level that the people are adding their value.
Absolutely, yeah, and because it's going to be more software based, the control, you sort of get more flexibility. So now let's move into the hardware part, because, you know, oftentimes say, you know, it's all software and you know, it's all software based, but at the end of the day, yes, but we do still need silicon at the bottom of it. Yes. You know, that need is not going to go away. And I think that there is with Open RAN, sort of initial assumption is that you can just go and put any off-the-shelf server, you're done. You know, yes. and then the software is completely separated, but it really doesn't matter what the hardware is, because you can use anything. And that concept, I think, is coming increasingly. Well, finally, we start talking about that. Is that really? So I think that, you know, yes, software very important, but it's the hardware part is equally important in making sure that you support the software, or well, actually, you support the functionality the way you to get what you need. So instead of thinking it's all up in software, it's like it's still software and hardware. The question is that what's the best choice on both? And what Open RAN gives you the opportunity to do is to treat the two choices separately.
Yes,
Right?
I mean,
And I don't know where, we can talk a little bit about that, but this is like sort of like at a higher level than what we talked about before.
Well, no, thank you for bringing up hardware. Of course, Picocom is a semiconductor company. So,
right. So obviously, yeah, but
yes.
it is sort of like the narrative of Open RAN. It's like software is all there is because you can use any hardware. And I think that there is a problem with that narrative. And I'm not telling just because you're selling silicon, I think that's something that we really need to pay more attention to.
Yes, I mean, it kind of goes, it's hardware. There was someone in the British Parliament, when 5G was coming along, said, oh, because 5G is all in software now, does that mean we won't need all these masts? Now, quite clearly, at one level, you need an antenna, you need a power amplifier and a transceiver and something to, get, so there's stuff that is obviously it's hardware, it's specific to a radio network. And then you get some stuff which, is fairly obviously software, like the core network, the central unit functions. I mean, well, say they're all software, or they may just be hardware that is shared, like smart NICs, things like that, things that are shared between, they're not specific to mobile networks. They're just about anything that's a transport network in potentially is, is a something that's it's not specific to a mobile network. And then you get things that are kind of, in between. And I think what we've been seeing, Intel obviously going back, a number of years now, I said, well, if we want to do as much as possible in software, that means we can sell more Xeon servers. So that's one point of view. But obviously what happens is the more, if you use something that's a general purpose architecture, whether it's Xeon servers or whether it's FPGAs, you've got quite a lot of stuff in there that you don't use for your specific application. So, you'll get the smallest, hence cheapest fundamentally, and lowest power solution if you use something which is actually just hardware that's specific to the application. So what you have there is a blend, and we're seeing the layer 2 processing, the MAC processing, you can do in software. It's quite difficult, it's hard real time, and it's possible to do. Parts of the PHY layer, you certainly do in software, but is that on a general purpose processor, or is it in something which is more specifically designed for the application? I think what you're seeing, if you look at what people have been announcing just recently, you've got Qualcomm and you've got Marvell, in particular. They've been for the DU and EdgeQ. In fact, for the DU, they've been pushing an inline accelerator card, and indeed Picocom for the small cell environment, we have an inline accelerator card as well, our Vanik solution, where the entire file layer processing and the potentially, certainly in our case, the eCIP3 open front haul is all performed in hardware offload on a PCIe card, which then means that any server, which could be ARM based or could be Intel based, is actually doing things which are the things that are really far better to do in software. So whereas Intel is actually going, they were suggesting that we'll do as much as possible on the Xeon, and we'll just have an offload card for the things that are too difficult. So I think that's where we've been seeing things. But if you look at what where Vodafone have gone, for example, the things they're looking at, and they are more concerned with massive MIMO, they've certainly seemed to have come down on the side of inline acceleration.
Yeah, absolutely, and I guess this is something that again, in sort of the narrative, it's sort of like being not talked as much, maybe, because so initially it's like you just use your basic server off the shelf and you're good. And then there is like, okay, hold on, we cannot just do that. We just need to have an accelerator. And I think that now there is an agreement that it's sort of like you need that for specific functions, because that's really otherwise it just becomes, you can do it, but it's just so inefficient that it's just not going to work, right? So that I think that's just the first thing. So we need to think about it in that respect. But the sort of the latest announcement from Intel talking about having the accelerator part being built in the server, I think it would suggest that we might be going towards a situation where we tend to have more customized hardware for the function. And there's just nothing wrong with that. And it's just not going to have any, it's independent from the choice of open or non-open RAM, because it's just basically realizing that something that is dedicated is just going to be more efficient. So there is a question of, how far do you want to go? Because clearly, the more dedicated, the more, the more sort of constraints you. The less choice you have in the hardware, because it has to be dedicated, and you don't want to go back to the proprietary sort of traditional approach either. So, how do you see that going?
Well, I'd say it's a very good point you bring up. Intel kind of incorporating, seemingly they announced with Rakuten said they were going to carry on using the Intel architecture, and that Intel announced with them they were going to take that forward error correction functionality, which is in an offload card currently, and then incorporate it onto the same chip as their server. Now, whether that's exactly what they're doing or not, we don't know. That's but it certainly indicates, they basically then have a an inline accelerator. The other interesting thing is people say there's that view, and I've used this argument in other companies in the past as well. It's to say, hey, I've got an architecture here that can do lots of different things. So when it's not doing a RAN, it can be doing edge compute. But actually, what you find out is that all these things kind of happen together. Your RAN, when you have peak load, the maximum number of users there, that's when you need maximum edge compute as well. So it's not like you sometimes need more edge compute when you've got less users on your RAN. It all maximizes together. So essentially, you're going to use those whatever resource you have on the end there. It's got to be dedicated to RAN processing anyway. And if you look at Intel processors, it's the expensive ones which have got all the extra stuff in them that are used for in the RAN anyway. So you can't just take any old standard off-the-shelf server and that's not been designed for the purpose. So we're seeing that anyway, across, if you go to AWS, it's all sorts of different AI acceleration things they got there. It's all stuff with special purpose compute that they're adding on to the general purpose there. And I think that's the way the world is. It's specific hardware for specific tasks. And I think Intel's basically endorsing that with what they're doing. But it's what I would say is, are you starting in the right place? Intel is starting with something which these things are hundreds of watts. They're not. They burn loads of power. And if you look at that Rakuten unit that they've shown pictures of, you've got a relatively small, thin unit. It's a rectangular thing with a couple of boards inside it. And then you've got these huge, great fins on for heat sinking. And okay, there's no fan there, and it's outdoors and it's pole mounted, but they've gone to great lengths to try and get the heat out, and it doesn't even support that many radio units. So is that the right place to start relative to starting, like say, well, Picocom or Qualcomm have started from saying, okay, how do we build the processing you require for a DU, and we'll put in there what's necessary with a balanced mix of hardware acceleration and processors that you can put software on.
Yeah, and I guess a sort of high level question here. You say how do you start, but I would say how do you end? I would ask you how do you end, because if you start going, if you realize, okay, off-the-shelf server not enough, we need accelerator. Then accelerator, we're building the accelerator. Then just seems like you might just keep going on that path, and you go on a path where you find out that in order to have the best power efficiency, performance efficiency, you're just going to go down further and further. So instead of having one special server with the accelerator built in, you just want to go deeper and deeper, more like towards what you're doing. And that seems like, why not? Because you still be able to take advantage of all the Open RAN type of functionality, because it's kind of an independent choice.
It is. I mean, I think that's kind of going full circle. This is not about, this is how about you're implementing whatever it is, how you're implementing closed RAN or Open RAN. The great thing about Open RAN is, and it should be, it's a layer above all of this. It's saying, I'm not dictating, or it shouldn't be. I know ORAN Alliance have had these blueprints for sort of reference design for how you do different units and everything, but that really shouldn't be what's happening. Open RAN should define how the whole thing fits together. Right. And that's how you make it open. You then make it say, well, I don't really care from an Open RAN point of view whether you're choosing to burn 300 watts and have lots of general purpose processing, or whether you want to do something in 20 watts and have it as something which is far more hardened and specific to the application.
Yeah, and actually, when I talk to operators, what they always say, they don't really care so much about having multiple vendors per se. What they care about is the flexibility. And so the flexibility extends to software and hardware, I guess, in the same way. And with hardware comes form factor, do you need cooling or not, all sorts of other things that have nothing to do with the topology itself. I mean, the interfaces and stuff like that. So I think that this is really, important to keep in mind. It's the flexibility that you get.
Yes, I mean, I think, a lot of operators would like to have flexibility. I mean, we're a small cell company, so but we're not a massive MIMO company where we do it. But we're seeing that mobile operators like to have the ability to choose the best kind of topology for their network in a particular place. I mean, I guess specifically, if you're going to use that split 7.2, you basically need to be installing, and we're looking for an in-building deployment, say, you need to be installing fiber to go from your DU probably to a front hall multiplexer, from there to radio units. There's quite a lot of bandwidth you have there. You need somewhere in that building to put your DU, so you need to have an agreement with the building owner or the tenants in that building to be able to do that. So there are lots of things there. So if you've got a lot of radio units and it's a large building, it's like a traditional DAS system, maybe, that's a similar sort of thing. Whereas if you've got maybe the building I'm in at the moment, we've got 6 floors, and you probably put 2 or 3 radios per floor to cover it. There's no necessary good place to you can put secure place. You can put your DU. You might make far more sense just to have that done using, say, a split 6 type of architecture, or integrated small cells in the building, and maybe an architecture you can actually build things. You can add on to things later. And I think a lot of operators do like to have that that ability to say, depends upon where they're installing something, they're going to do something that is optimized for the purpose, rather than just having a one size fits all.
Yeah. Now, another issue which is related to the silicon choice, the hardware choice, is power consumption. So operators are increasingly concerned, and rightly so, about reducing consumption or increasing efficiency, which is, I guess, the best way to go. But so the question there, sometimes people claim, well, with Open RAN, you're going to save energy, and well, it really depends on how you go about it. You might save energy compared to whatever the legacy network, because you're just using better, more efficient equipment. But it doesn't necessarily mean that Open RAN translates into lower power consumption. And in fact, it might not be the case if you're using off-the-shelf hardware, because off-the-shelf hardware is efficient for what it does. I mean, in general, in terms of, but it's not efficient in terms of running in what you're trying to do.
Yes, I mean, something so in small cells. I mean, what they're called, generally speaking, they're passively cooled. There's no fans, so
right.
If most of the kind of DUs that we see now are based on servers, they have fans in. They have to be put somewhere, in a cooler environment, and we're seeing, I think, particularly in Europe now, with the cost of energy going through the roof. Going back, a year or two, people do care about how much electricity how much money they spend on electricity. But one of the fundamental things is, how do you get the heat out of things? Do I need fans? Do I, how do I install this? So you want to reduce the power consumption just so that you can, it's from that heat dissipation. Now, it's the cost of electricity is becoming a huge factor. So there'll be an even bigger push, we have customers of ours who are looking to evaluate this, an Open RAN style deployment of, do I actually have a server with a plug-in card, or do I take an ARM-based NPU sort of processor, from someone like Marvell or NXP, and put that on the same board as the PHY chips, and have something which is generally far more optimized to reduce the power consumption. This is something you can do. Small cell networks, it's far more about kind of putting things together. It's kind of small. It's smaller scale and lower power. So we're seeing all of those things now. That's being pushed by a desire. It's not just a desire to kind of reduce the heat, but it's just reduce the electricity consumption.
Absolutely, yeah, and well, so reduction in power consumption is that it's expensive, so you want to keep costs down. It's also, you want to be meeting new power consumption goals, whatever. So this is really this is not a detail, and so I guess that's really another really sort of strategic, or really, it's really a fundamental choice, that the more dedicated the hardware is, the more, and I guess there is a question that the software has to be efficient to, drive efficiencies as well, but that, I guess, it's independent on the hardware. And in general, I guess you could say that hardware, the more dedicated the hardware is, the more, other things being equal, it's going to be more power efficient. So if we can generalize.
Yes, I think just running out of time, but an analogy there is, when Apple brought out their M1 processor, battery life is far longer, and it did better on so many benchmarks than x86 based laptops. And kind of, why was that? Well, okay, there's an efficient implementation of the silicon. You've got some ARM cores which are capable. You've got a unified memory architecture, and that's what allows you then to have separate processors for video encoding and decoding, for ML acceleration, for graphics acceleration, for DSP sort of functions. And these dedicated processors, they're far better at doing the one particular function. And when they're not being used, they get turned off. So they're consuming basically no power. And that's what a dedicated architecture, if you look at a Picocom PCA2 chip, you know, okay, things are being turned on and off on a sort of sub-millisecond basis, but you know, they do their processing, they get turned off, and each one is optimized for its task. And that's where you gain a lot from having something that's optimized. You have the thing is doing a specific task, that's what it does, and then you turn it off, rather than having something that's this general purpose and it has a lot of overhead that's running all the time.
Yeah, I realized we're at the top of the hour. I was just like,
Yes.
time flies. And so, well, Pete, thanks a lot. And I'd like to thank the audience. And we need to give it back to Kendra.
Okay, great. Thank you, Monica. That will conclude our webinar for today. Thanks again to our speakers and thanks to our audience members for those great questions and comments. A recorded version of today's webinar will be made available on the sensafili.com website in the coming days. And we also have some links in the chat box for a deep dive on this topic that you can check out. Thanks again, and we look forward to seeing you at future events.